In question 6, we've been given the following diagram and we're told PQ is a tangent, this is a cyclic quad, and we've got a couple of straight lines, and these two lines are parallel, quite important. Then we need to prove that A is equal to B2. So I can start with any one of these two angles, but before I do that, let's glamify our sketch a little bit, but yes, it's nice, bro. Okay, so I'm going to start off with B2. So B2 is located over here, and I want to follow it back to its chord. So if we look at B2, we look at the two lines touching B2, line BD and BC, and we follow it back, and we follow it back some more, and we get to the chord DC. And I know a sneaky theorem with a chord and a tangent, but the tan chord theorem. And that theorem goes a little something like this. The angle between the tangent and the chord will be equal to the angle that that chord subtends. And remember, it works both ways. I can use this angle between the tangent and the chord and follow that down to get this angle. So over here, I know that angle C1 will be equal to B2 because B2 is subtended by this chord, and the angle between the chord and the tangent will be equal to that angle. So I know that C1 is a red angle. And we are going to state it just like this. B2 equals C1 due to the tan chord theorem. Now I'm going to focus on C1 and see what I can do with C1, maybe try relate it to A somehow. So if I have a look at those two angles, I can see like both of them are touching the parallel lines. So I can apply my parallel line theorems, and I see some alternating angles, but I see the Z. Can you see it, my bro? So A1 will be the same size as C for alternating angles. And to briefly run through that theorem, if the lines are parallel, then like these angles in the armpits of the Z or the N will be equal. So I know that C1 will be equal to A, and this will be my reason, alt angles, and then we've just got to modify the parallel lines to suit ours. So ours will be line AB is parallel to PQ. So let's get that written down. And we just stated like this, angle A is equal to angle C1, because the alt angles, semicolon AB parallel to PQ. Next up, we can see that B2 equals C1 and A is equal to C1. If they equal to the same thing, they have to be the same size. So B2 is equal to A. And then you don't really have to put a reason for that line. If you do want to put a reason, you can tell me like they both equal to C1. And then we're going to quickly run through where the 4 marks come from in this question. So we get 1 mark a pop for each statement. And then we get 1 mark a pop for each wee little reason. And now we have to prove that D3 is the same size as D1. So I'm going to choose one of these angles to start with. I think I'm going to choose D1 because I can see that that's an exterior angle of a cyclic quad. And I know a theorem that deals with the exterior angle of a cyclic quad. And that theorem goes a little something like this. The exterior angle of a cyclic quad will be equal to the opposite interior angle of the cyclic quad. So if we apply that here, this exterior angle of the cyclic quad, I follow it across to the opposite interior angle. So it's going to be equal to the whole of B over here. So let's get that written up. And we just write it up like this. D1 equals B1 plus B2, exterior angle of cyclic quad. Now I'm going to see what I can do with this orange angle. And look what that orange angle is touching. It's touching a parallel line. So I can do a Z with that orange angle. Alternating angles, my bro. And to show you that a little bit more visually, we can see the Z over there. And the alternating angles will be equal. So we're going to write that up just like this. C3 is equal to B1 plus B2. Alt angles, and that's because line AB is parallel to the line PQ. And now I'm going to have a look at this orange angle and see what I can do with it. And if I look at this orange angle, it's touching a tangent and it's touching a chord. So I'm going to follow that chord up and up again, and we get a winner chicken dinner. We get to D3. So D3 is also an orange angle. Okay, so let's state that. And we utilize that theorem in the previous question. It's the tan chord theorem, and we say that C3 is equal to D3 because of the tan chord theorem. Now we're going to start with our conclusion. So firstly, we need to make the link between these two angles. Because D1 and C3 equal the same thing, they both equal B1 plus B2, we're going to state that they are equal to one another. And if you would like, you can mention the reason that they both equal B1 plus B2. And then we see that C3 equals D1, C3 equals D3, and C3 also equals D1. So it stands to reason that these two have to be the same. So we're just going to hit a therefore D1 equals D3, and we've adequately proved what they are asking us to do. So let's have a look where the 5 marks come from. First mark comes from your statement. Second mark comes for your reason with the exterior angle of cyclic quad. The third mark comes from the statements and reason with the alternating angles. And then the fourth and fifth mark come from the tan chord theorem with its statement and reason.